Okay, here in example 3, we're going to combine the fractions and then simplify to a multiple of a power of a basic trig function. And so I gave you an example of what I mean by that. I mean 3 tangent squared of x. Not that that's going to be the answer, but the answer will be something to that effect with a coefficient and then a power of a basic trig function like sine or cosine or tangent or cosecant or something to that effect. And so what we're going to do is combine the fractions, and so that means finding a common denominator, and so the common denominator is just going to be the product of sine squared and tangent squared. And then for the first fraction, we're going to have to multiply by tangent squared. And so tangent squared times 1 is just going to give tangent squared of x. For the second fraction, we're going to have to multiply by sine squared x, and so that's going to end up giving me secant squared x times sine squared x. Now, here's where I'm going to focus my attention moving forward, is on this term right here, because I noticed something, that secant squared x is really the same thing as 1 over cosine squared. And so watch carefully what's going to happen here. I'm going to replace secant squared with 1 over cosine squared, and that's going to be multiplied by sine squared x, all over sine squared x times tangent squared x. Okay, now this second term in the numerator is sine squared over cosine squared. And I know by a quotient identity that sine squared x divided by cosine squared x is tangent squared x. And so I'm going to be able to replace that second term with tangent squared of x. Okay, this is looking really good right now. In the numerator now, I have 2 like terms that I can combine. So tangent squared x plus tangent squared x is going to be 2 tangent squared x divided by that same denominator that we've had this entire time, sine squared x times tangent squared x. And now, because this is multiplication in the denominator, we can cancel tangent squared and tangent squared. And so that's going to end up giving me 2 divided by sine squared of x, which is going to reduce using a reciprocal identity to 2 cosecant squared of x, since cosecant is the reciprocal of sine. Okay, we want to follow the same directions here, combining the fractions and then simplifying to a multiple of a power of a basic trig function. And so I'm going to start by finding a common denominator, and so that's going to be sine x times cosine x. The first fraction has sine x, it is missing cosine x, and so we're going to multiply that numerator that's already there by the part that's missing from the denominator, which is cosine x. And then in the second fraction, the denominator is missing sine x, and so we're going to multiply what's already in the numerator, which is a sine x, by another sine x, which is going to give us sine squared of x. Now, watch what I'm going to do next. I notice that secant x times cosine x, those are reciprocals of one another. We're multiplying them together, and so therefore the result is 1 minus sine squared of x divided by sine x times cosine x. Okay, the next thing that I hope you're noticing is that this numerator is a rearranged version of that first Pythagorean identity. And so therefore, 1 minus sine squared x is going to equal to cosine squared of x. And so I'm going to replace that numerator with cosine squared x, and it's going to be divided by sine x times cosine x. Now, because everything is being multiplied here, what can happen is that I can reduce my cosine squared over my cosine. And so cosine squared is just going to be cosine to the first power, and that's going to cancel out that cosine. And so what we're going to end up with then is cosine x in the numerator divided by sine x, which by a quotient identity is cotangent of x. Okay, finally in example 4, we're going to factor each expression, and the final version is going to be an algebraic expression of a single trig function. So for example, 2 sine x plus 3 times sine x minus 1. And so here in example A, I have cosine squared x plus 2 cosine x plus 1. And so this is in what I call a quadratic form, which means this factoring is going to be a lot like factoring x squared plus 2x plus 1. It's just that instead of x, we have cosine x replacing x. And so how would I factor this quadratic? Well, because the lead coefficient is a 1, I just need factors that multiply to 1 and will add to 2. And so that would be 1 and 1. And so therefore, this is going to equal to cosine x plus 1 multiplied by cosine x plus 1. And that would be the final factored version of that original expression. Okay, last problem here, and this is again a factoring problem, although it's going to take some work to get there. And so what you're going to do is you're going to let yourself be led by the quadratic term. And so notice here that I have tangent squared x. What that means is I want to try to get everything to be in terms of tangent x. And so I notice here that I've got 4 over cotangent x, and I know that with a reciprocal identity, I can write that as 4 tangent x. Now, for the last term, I have sine x times cosecant x. What I recognize about those two things is that they are reciprocals, and when I multiply two things that are reciprocals together, the result is 1. And so using some basic identities, we cleaned this up to where now it is in quadratic form, and so it's going to be a lot like factoring 4x squared minus 4x plus 1. And so to factor that quadratic, since it has a lead coefficient of 4, then I need to multiply the ends here, and 4 times 1 is 4, that's my multiply number, and my add number is negative 4. And so that would be negative 2 and negative 2, and because that lead coefficient is not a 1, we're going to have to factor this the long way. And so here in the middle, I'm going to have minus 2 tangent x, minus 2 tangent x, and then plus 1. From the first two terms, we can factor out a 2 and a tangent x, and that's going to leave us with a 2 tangent x minus 1. From the second two terms, we can take out a minus 1, and that's going to leave us with a 2 tangent x minus 1. And so what we're going to have here is 2 tangent x minus 1 multiplied by 2 tangent x minus 1. Okay, that's going to do it for basic trig identities and simplifying expressions. And if you guys have any questions, then please feel free to reach out to me.